Okay, don't worry about this word called mutually exclusive. It just means that they are not related to each other. Alright, rather I would like you to zoom in on the word or. Anytime you see this word or, most likely you can add the probability together or add the events together, provided they are not related. So I'll use this word not related. And later we'll see the example a little bit more. Alright? So, okay, as you tell me, very good. There are 4, 7. So very quickly, 4 over 52. Please remember to reduce the lowest term, 1 over 13. So take note, in picture cards, we mean jack, queen, as well as the king. So each particular shape, there are 3 pictures. Total, there are 3 times 4 of 12 pictures. So 12 over 52. Again, need to reduce to lowest term. Okay, you'll get 3 over 13. Okay, now it's the first time we see that keyword called or. Oh, Mr. Liu say, whenever I see the word or, I can add them together. Or whenever you see the word or, provided they are not related. Provided they are not related. So that is the criteria. The number 7 comes from part 1. The picture card comes from part 2. A 7 can never be a picture. A picture can never be number 7. So basically, they are not related. Alright? If they are not related, they are mutually exclusive. Meaning, I can add the 2 answers from part 1 and part 2 together. That's one method. Okay, so this is basically just summing up the probability for the 7 as well as the picture card. However, there's a longer method. The longer method just count how many 7 are there? 4. How many picture cards are there? 12. Same thing, you add up the 7 and the picture over the total number of cards. You will get 16 over 52, and when you reduce to lowest term, you will still get 4 over 13. So basically in part 4, I don't want the 7, neither do I want a picture card, but there are a lot of other cards. So rather than counting everything together, you all told me it's easier to use the elimination method. 1 minus what I obtained in part 3. Okay? How many diamonds are there? 13. So very quickly, I'll just write down for part 5. Oh, there are 13 over 52. This will give us 1/4. Okay, but I'm going to put a star at part 6. Think, a 7 or a diamond? Hey, I know what is a 7. I also know what is a diamond. Can I add them together? Okay, so you notice a number 7 can also be a diamond. Am I right? Okay, so there are 2 ways of doing so. Take a look at my first method first. How many 7 are there? 4. How many diamonds are there? 13. But the 7 can be a diamond as well. Am I right? So I cannot add them together. After I add them together, I need to minus 1. You agree? Because you are repeating it twice. So I need to minus 1. So in this case, whether it's a 7 or a diamond, there are only 16 outcomes. So I can do 16 over 52. And then after that, reduce to lowest term, I will get 4 over 13. Alright? To me, this is the easier method. Another way is, teacher, I still sum them together. I get the probability of having 7. I get the probability for getting a diamond. So for getting 7, you have this answer. For getting a diamond is in part 5, you get this answer, plus 1/4. But you minus off the probability that, oh, it's going to be a diamond as well as a 7, and that is 1 over 52. Okay? But this one, I don't like the answer. Okay? I don't like this way of presenting, so I will strongly discourage this one because it's quite confusing. So I'd rather you count the double count one, just subtract 1. Alright? Okay, looking at this question, what Javier said, oh, these four numbers, let's add them up. Okay, since the four fraction or probability, when we sum them up, we get this fraction, and this is clearly not equal to 1. That means this cannot be the only 4 teams inside. Am I right? This cannot be the only 4 teams inside. So there cannot be only 4 teams. So if there cannot be any 4 teams, only 4 teams, there must be more than 4 teams. So I mean, it sounds logical, but you just have to write it out lah. So there must be more than 4 teams.